Hello, how are you? And welcome. We're going to talk about 3D geometrical solids, or we're just going to try to understand 3D shapes one more time, just in case the first video wasn't enough. It's a fun concept. It's not the hardest concept, but it's really cool and interesting to play with. Essential words. Make sure you're checking your note frames if you're doing this on your own for essential words. If not, you'll want to pick those up in class. But if you're just listening, you'll probably pick up a few on your own, even outside of class. Take a look at this. What geometric solid do you suppose this will make? What if we took this net and we folded it and we put it together just the right way? What might it look like? Well, if you're thinking that it's a cube, then you are correct. There are lots of different geometrical solids out there. 3D shapes, cubes, spheres, prisms, pyramids, cones, cylinders, and you have to be pretty comfortable with most of them. But yes, if you thought this was a cube, this is generally the easiest one to classify because it's the only one really where it's just a bunch of squares put together, a bunch of perfect squares all together. So if you see that, chances are you're making a nice perfect cube. Let's practice some more, though this time let's do it with some multiple choice. Look at this cube. Which one of these will make the cube? Now there are a couple options that you could pick, but they're tricking you. B is a trick, because even though it does have some perfect squares, it's got triangles on the side. And to be honest, that's going to make some kind of weird triangular prism. Yeah, when it has like a rectangle-ish bottom and other sides, it's going to be a prism of some sort. This would make just a rectangular prism because it has a rectangle bottom and rectangle sides. See how that works? The bottom tells you like if it's a prism or not, and then the sides tell you what kind of prism. Rectangular prism. Triangular prism. Isn't that kind of neat how that works? But the cube over here is going to get made by C in the end, because that's the only one that has all the perfect squares put together that you could fold up. This has some squares, but then those are just the sides, and it's got mostly rectangles, doesn't it? As a bit of practice, shall we count how many faces, edges, and vertices this have? Let's take a look at the cube. F for faces. 1, 2, 3, 4, 5, and then in the back, 6. Like the one that you have to like see through the shape, you know? There's 6 faces. How about vertices? Those are the inside corners. 1, 2, 3, 4. Don't give up though. Look at the top. 5, 6, 7, 8. All right, 8 vertices. And how about edges? Ooh-wee, how about them edges? Let's see, I'm going to use a different color so I don't get too confused. If the thing will let me. Okay, cool. So let's trace it. 1, 2, 3, 4. Going down. 5, 6. These are all edges. 7, 8, 9, 10. Are we doing this right? 11, 12. Did we do it? Did we do it? I think we did it. 12 edges. Basically, the edges are anything, like any line that you could take your finger in real life and kind of like trace it with your finger and feel the edge. You know what I'm saying? All right, let's move on. This is a cuboid. I've never really seen it called a cuboid that much. Usually I would say it's a rectangular prism, but perhaps cuboid has a special definition, or it's another way of saying it. We're going to cut this out. We're going to fold it together. Same thing with this guy. This is a hexagonal prism. Whoa! How do you even know the name of that, Mr. Graham? What madness are you speaking? Well, here's the tough part. It's got a hexagon, right? And it's got all these square or rectangle sides. And if it's got square or rectangle sides, and some other weird shape as the base, that's how you know it's a something prism. So it could be a pentagonal prism if there was a pentagon on the bottom. A pentagon has 5 sides though. As you can see, this shape has 6. And 6 is for hexagon. So this is a hexagonal prism. Here's a weird thing to ask. What if, like, it had hexagons, but instead of squares here, it had a whole bunch of triangles? What do you think it would be called then? Well, I'm not sure how difficult or easy it would be to make that shape, but I can tell you one thing. It would still be a hexagonal something. It'd be a hexagonal pyramid of some kind. Because the triangle sides that all come up together will look like a pyramid. It's just that the base will be a hexagon, so there'll be like 6 sides to it. It'll be a hexagonal, 6-sided pyramid. Here's a cube, nothing fancy to work with, but if you at all paid attention to me blabbering on this page about practicing the faces, vertices, and edges, I'm sure that discussing this with a partner, or doing it by yourself if you prefer, would not be that hard. And last but not least, once again, I need you to make these shapes. It's a little bit harder because this hexagonal prism might take some patience. This cuboid or rectangular prism might take some patience, but make them. That's 1. Draw what they look like from the side, the front, the back, the top, the bottom. I mean, when you look at them unfolded, you can see, like, oh, the bottom and the top, I can see those are hexagons. From the sides, oh, I see, they're going to be like squares or rectangles. You know, it depends how closely you're paying attention. So draw what they look like and label them. And then I want you to count the vertices, faces, and edges, just like we did together right there. Alright guys, if you can do all that, then you're understanding your 3-dimensional solids very well. I'll talk to you next time. Have a good day. Bye.